right, guys. Hey, today we're going to talk about combining like terms and what that means. So if you were in Math 8 in a Virginia school, especially a Prince William County school, you should have some familiarity already with combining like terms as far as solving equations goes. And that's what we're going to use it with. And so I'm going to start by filling out the notes, and as I'm filling out, I'm going to talk and explain to you so that you can always come back to this video to look at if there's ever something that you can't remember and you wish you could hear what I said again. So remember that in an equation or an expression, a term, let's see if we can get the pen going here, a term is a constant or a variable with a coefficient. So remember, a constant is just a number. And it can be a positive number, it can be a negative number, it can be a fraction, it can be a decimal. These are constants, okay? A variable, you may remember, is a letter, and a coefficient is the number in front of that letter. So for example, for x, that's a variable term. Negative 10y, that's a variable term. 1/2, well, I guess I wrote a negative 1/2 t. That's a variable term. Okay, so we have constant terms and we have variable terms, and these are the parts that make up our equations. Like terms are terms that are, surprise, alike. That is, they are either all constants, or if they're variables, they have the same type of variable. So for example, 4 and negative 10 are like terms because they're both constants. I don't know if you can hear my cat meowing in the background. She always likes to start meowing as soon as I want to do a video. 1/2 and 2.1 are like terms because they're both constants. 4x and 12x are like terms because they both have the same variable. 3y and negative 8y both have the same variable. 1/2 w and negative 3w. The fact that one of these is a fraction doesn't matter. Since they both have the w, that makes them like terms, okay? So unlike terms are when you mix any of those. Like if you take the 4 from the constant and the 4x from over there, these are not alike. This is a constant, this is a variable, not like terms. If you took the 1/2 from here and the negative 8y from here, these are not like terms because this is a constant and this is a variable. If I took the 12x and the negative 3w, these are not like terms. They're both variables, but they're different variables, okay? One's x and one's w. So in order to be considered like terms, your numbers either have to be all constants or all the same variable. Once we know about like terms, we will know that we can add and subtract them just like integers, but unlike terms cannot be added or subtracted. So for example, if I look back up at what I just drew here, and let me get a different color, I could do 4x plus 12x because they're both x's. I could do 3y minus 8y because they're both y's. But I could not do 4 plus 4x, for example. That's not possible. 12x minus 3w, this is not possible. You can only add or subtract if they have like terms, if they have the same variable. So the adding and subtracting part is really easy. The calculator will do it for you. Some of us are not very good at integers. We tend to mess up positives and negatives. And the great thing is that we have access to the Desmos calculator, which will take care of those positives and negatives for us. We just have to make sure that we don't miss any of the details. So the easiest way that I have found to combine like terms is as follows. And I'm going to change colors here because I like this pink. Step 1 for me is to draw circles around the variable terms, and you must include the signs. You'll see how important that is in just a minute. Step 2 is to draw boxes around the constant terms, and again, you must include the signs. And then finally, you're going to combine your variable terms first and then your constant terms. And the signs are going to tell you if you're supposed to add or subtract. So that's how you know what to do, which is why you need to put those signs inside the boxes, okay? I'm going to zoom in a little bit to make this nice and big, and we're going to look at this first example. So it's said to draw circles around our variables. Well, the first variable I see is 3x, so that's going to get a circle. And the other variable is the 4x. Now, do you see how there's a plus in front of it? You want that plus to be in the circle along with the variable term, okay? You're going to put a box around your constants. 14 is a constant, and we're going to put the minus in the box with it. 9 is a constant. We're going to put the plus in the box with it. The sign that goes with the number is always the one in front of the number, okay? So, for example, you wouldn't circle 14 plus, because if you're going to write positive 14, you write it with the plus in the front, okay? If you wanted to write negative 3x, you wouldn't do it like this. You would do it like this. So the sign in front of the number to the left is always the symbol that goes inside the box or the circle. Let me erase this. So having those boxes and circles, we can very easily figure out what to do math-wise. Let me switch over to blue. 3x, and then see the plus 4x. That's how I know whether to add or subtract. Well, 3 plus 4 is 7. So 3x's plus 4x's is going to be 7x's. Then I look at my constants. Negative 14 plus 9. All right, well, let's say that I'm not so great about negative 14 plus 9. I'm not too good at the negatives. I'm going to use the Desmos calculator. And you can see on my top row here, negative 14 plus 9 is negative 5. So that's going to be minus 5. Negative 5 we write as minus 5. And there you go, we have just combined our like terms. We put our x's together and we put our constants together, so we have a shorter expression, okay? Let's look at the next one down. Let's switch colors again. How about turquoise? So again, we're going to circle our variables. So our first variable is negative 12k. Our second variable is negative 1k. And our third variable is positive 6k. Our constants are plus 6 and minus 8. Now, here's where you need to be careful about your boxes and circles. I've seen a lot of kids do like this with their box. They only go part way through the sign, and then they can't read their own handwriting. They can't tell if that was a minus or if that was a plus, and they drew over it. That's why you have to be very careful to put the whole symbol, including the sign, inside your box or your circle, okay? So look at your K's. We've got negative 12 minus 1 plus 6. So if I go to my calculator, look at the second row, negative 12 minus 1 plus 6 is negative 7. So I'm going to go back over to here, and I'm going to put negative 7k, because those all had k. All right. Now I'm going to look at my two boxes. 6 minus 8 happens to be negative 2, so I'll put minus 2. And there is the answer to that one. Okay. Let's look at one more here at the bottom. Let's switch colors again. How about purple? All right. I'm going to, again, circle my variable terms. Look real carefully for a second and think in your head which ones you think are the variable terms. All right. Hopefully you said 6w, minus 3w, and minus 3w. That means your constant terms are minus 5 and plus 8. So we're going to combine our variables first. If I start with 6w's and I take away 3w's, that gives me 3w's. And if I take away another 3w's, I will have 0 w's. Looks like ow. And then if I have negative 5 plus 8, if I use my calculator, the calculator will tell you 3. And if you look here at the bottom row, see negative 5 plus 8 is 3. Well, I can't just write 3. Let me slide this up a little bit. I can't just put 3 like this. There has to be a plus or a minus in between every term. So if I ask you the number 3, is that positive or negative? Hopefully you would tell me that 3 means positive, which means we have to put a plus sign there. Now, this answer is mathematically correct, but we can actually simplify this a little bit more. What is 0? If you have 0 W's, you have nothing, right? What's 0 times anything is 0. And what is 0 plus 3? In this case, the W's ended up canceling themselves out, and all we have left is 3. Okay, so here's your quick and easy explanation about how to combine like terms. We are going to be doing some practice problems with this next time I talk to you.